All right, today we're diving into the science behind the 2023 Nobel Prize in Chemistry. And trust me, this is a big one. It's a discovery that has literally changed the color of our world, from the amazing screens we carry around to the lights in our own homes. So let me start with a pretty wild question for you. What if color wasn't about pigment? What if it was just a property of size? Imagine changing something's color not by adding a dye, but just by making its particles smaller. I know, it sounds like something out of science fiction, right? But it's very, very real. It's the magic of nanotechnology. And well, answering that very question is what earned these three scientists, Mungi Buendi, Louis Bruss, and Alexei Yekimov, the Nobel Prize. These are the pioneers, the architects, who discovered and, maybe more importantly, perfected what we now call quantum dots.
Okay, so let's get into it. What in the world are quantum dots?
Basically, a quantum dot is a teeny tiny man-made crystal. We're talking just a few thousand atoms across. They are so ridiculously small that the normal rules of physics just don't apply anymore. Instead, the weird and wonderful rules of quantum mechanics take over. And the most important rule for us right now is a simple one. When you get this small, size changes everything. And I mean everything, especially its color.
You know, a really good way to wrap your head around this is to think about a guitar string. When you shorten the string by pressing on a fret, what happens? You get a higher note, a higher frequency. While quantum dots are kind of like that, but instead of making sounds of different pitches, they create light of different colors.
So check this out. If you have a really tiny dot, let's say about 2 nanometers wide, the electrons inside are super squeezed together. When you hit it with light, they get all excited and then release that energy as a burst of high-energy blue light. But if you make the dot a little bigger, maybe 6 nanometers, those electrons have more room to breathe. So when they get excited and release their energy, it's a lower energy light, which our eyes see as red. And the coolest part? By just tweaking the size between those 2 points, you can create literally every color in the rainbow. It's all about the size.
Now, this whole discovery didn't just happen overnight. It wasn't one of those eureka moments in a lab. No, this was more like a scientific relay race, with each incredible researcher basically handing off the baton to the next, building on each other's work for more than a decade.
Yeah, this journey to get these things just right took a while. It all kicked off in the early 80s with Alexei Yekimov. He was the first one to spot these weird size-based color effects, but he saw them in colored glass. Then, just a couple years later in '83, Louis Bruss came along and proved the same thing could happen with particles just floating around in a liquid. And then, the final piece of the puzzle, the real game changer, came in 1993 when Mungi Buendi figured out a revolutionary way to actually make them perfectly. Let's dig into each of these steps, because they're all super important.
So first up is Yekimov. He's studying colored glass, and he sees something strange. He realizes the color of the glass wasn't coming from some dye mixed in. No, it was actually changing depending on the size of these microscopic crystals inside the glass itself. This was the first clue, the first hint that, hey, maybe size itself could control how matter behaves at the quantum level.
Okay, so then Louis Bruss enters the picture over at Bell Labs. He manages to create the exact same effect, but not in solid glass. He did it with particles just floating freely in a liquid. Now this was huge. It proved this wasn't some weird quirk of glass. This was a fundamental property of matter. He basically took the discovery out of the glass and put it into a flask, making it way easier to study and understand. But there was still a major problem. See, these early quantum dots were, well, kind of messy. They were flawed, inconsistent, you couldn't really rely on them. And that's where Mungi Buendi comes in and changes everything. In 1993, he cracked the code. He developed a completely new production method that let him create perfect, uniform crystals whenever he wanted. This was the breakthrough. This is what turned quantum dots from a cool lab curiosity into a real, usable technology that you could actually mass produce. And honestly, Buendi's breakthrough is the reason we're even talking about this today. It's why this incredible science isn't locked away in a laboratory. It's probably sitting in your living room right now.
Seriously, once we could make them properly, quantum dots started popping up everywhere. They are the Q in your QLED TV. They make our LED lights way more efficient. They're even used in medicine to help surgeons see tumors more clearly. And we're just scratching the surface. People are looking at them for better solar cells, flexible electronics. The list just goes on. So let's talk about your TV screen, because this is where you really see the difference. Old school displays, right? They worked by shining a big white light through a bunch of color filters.
It was really inefficient, wasted a lot of energy, and the colors were kind of washed out. But QLED screens, they do something way smarter. They use an efficient blue light to zap a layer of red and green quantum dots. Those dots then glow, emitting perfectly pure red and green light. No filters, no wasted light, just pure, brilliant, eye-popping color. And the result? It's just a massive leap in quality. Because these dots emit light at such specific, pure frequencies, they create the purest colors we've ever been able to produce on a screen. That means QLED displays can show you millions more colors, more accurately than anything that came before. The picture isn't just brighter, it's just more real.
So when you boil it all down, here's the takeaway. This incredible scientific journey, from seeing a weird effect in colored glass all the way to a revolution in manufacturing, has put some of the most advanced science on the planet right into our homes. It's literally making our world brighter and more colorful. And that leaves us with a pretty mind-blowing thought, doesn't it? We can now create materials where their properties don't come from what they're made of, but just from how big they are. We are literally learning how to build matter atom by atom. So the question isn't really what can we build anymore. The real question is, what amazing problems are we going to solve next?